Hello, my name is Gregory Asplund, and I am an elementary learning strategist at West Prep Academy in Las Vegas, Nevada. In this video, I will be presenting the Making 10 strategy for mental addition. My goals for this video are for viewers to understand how to use the Making 10 strategy for mental addition, and also for viewers to understand how the Making 10 strategy can be applied throughout the place value system. This is a 10 frame. It can be used as a visual model for students to see how numbers interact to create combinations of 10. I'm using this 10 frame to model the addition problem 9 plus 1. I currently have 9 counters on the 10 frame, and we can see that there's room for one more. That's my plus 1. I have room to put one additional counter onto my 10 frame. From there, I can visually see that 9 plus 1 more is going to make 10. I have set up another 10 frame with 9 counters, but this time I want to explore 9 plus 3. Looking at my 10 frame, I see that I have room for one more counter on my 10 frame. So now I know that I have 10. But if I consider my counters, I know that I still have 2 more to add, because I want to add 3 total. So I end up with 2 of my counters off of my 10 frame. I'm able to see that I have 1 full 10 frame, and I have 2 additional. So I can see that 9 plus 3 is really the same thing as 10 plus 2. I know that 10 and 2 more makes 12, so 9 plus 3 must be 12. Once I have enough experience with the 10 frame, I can start mentally considering how 9 is 1 away from 10. So I could look at a problem like this, 9 plus 7, and I could reconsider my add-ins. 9 is 1 away from 10, so if I compensate and take 1 from the 7, I can make that 9 into 10, but that leaves me with 6. So 9 plus 7 is the same thing as 10 plus 6. 10 and 6 more gives me 16, so 9 plus 7 must be 16. As I become more advanced with this strategy, I can also start considering the relationship between 10 and some other numbers. In this case, I see 8 plus 5. I know that 8 plus 2 is going to give me 10. So if I could somehow compensate, if I could take 2 from that 5 to make 10, I might be able to make this addition problem easier. So I'm going to break apart this 5. I know that I need 2 to make that 10, so I'm going to consider this 5 as 2 plus 3. This 2 can be combined with this 8. 8 plus 2 is 10 plus 3 more. I know that 10 plus 3 is 13, so 8 plus 5 must be 13. Here we can consider another addition problem. Intuitively, when we make 10, we might want to start with the add-in that is greater. But in this case, I really solidly know that relationship of 5 plus 5. That's oftentimes the 1-10 fact that students learn first. So I see 6 plus 5. I can reconsider this 6 as 1 and 5. And then I have 5 as one of my original add-ins. I see 5 plus 5. I know that 5 plus 5 is 10 plus 1 more, so 6 plus 5 must be 11. This is an example of how this strategy was used in a mini lesson with 3rd graders. We start out by presenting 6 plus 4. The students were able to pretty quickly solve that as 10. One student was able to model that as 6 plus 4 being the same thing as 5 plus 5 on a 10 frame. The next step was to consider 6 plus 5. Since we had already worked with 6 plus 4, One student recognized that 6 plus 4 plus 1 more was 6 plus 5. Since 6 plus 4 was 10, 6 plus 4 plus 1, or 6 plus 5, must be 11. 6 plus 4 and 6 plus 5 were then taken into two-digit by two-digit addition problems, modeling how making 10 can be done within these two-digit problems and the relationship the making 10 strategy has with the traditional algorithm for addition. Once students become comfortable with the making 10 strategy and comfortable with double-digit addition, that making 10 strategy can be applied in these situations. One way that this could be considered is if we look at our ones place, we have 5 plus 6. Well, 5 plus 6 could also be 5 plus 5 plus 1, which gives us 11. If we look at our tens place, we have 60 plus 20, which is 80. And then finally, we can add our 80 with our 11 and see that 65 plus 26 is going to give us a sum of 91. As students become more advanced with the idea of making 10 and compensation, they may not even need to consider the ones place separately. Again, here with the same problem, 65 plus 26, we could possibly look at 65 and know that 65 is 5 away from 70. So I'm going to consider that 65 as 70. But in order to do that, I must take 5 away from my other addend. So instead of considering my second addend as 26, I'm going to think about it as 21. I've redistributed the numbers that I'm going to add together, so instead of having 65 plus 26 and needing to regroup, I've taken 5 from the 26, given that to the 65, I have 70 plus 21, that is 91. The making 10 strategy can even be extended to 3, 4, 5-digit addition problems because, again, we're working on our system where our ones, once we have 10 ones, we move into our tens place. Once we have 10 tens, we move into our hundreds place. Once we have 10 hundreds, we move into the thousands place. This continual building on the number of 10 as we move through the places allows us to use this make 10 strategy in any place. So if we consider 184 plus 227, I can look at that 227 and know, just by looking from the ones place, that if I give 227 3 more ones, I can have 230. But those 3 more ones have to come from somewhere. I've taken them from the 184, and now instead I'm going to consider that as 181. So now I have 181 plus 230. I move into my tens place, and I want to work with 181 because I see 8 tens in the tens place, and I know I only need to compensate with 2 more tens to make that a friendlier number to work with. So I know I need 2 more tens, so I'm going to take that from my 230. I can consider my 230 to be 210. And those 2 additional tens turn 181 into 201. So now I have 201 plus 210, that's 411. In another example, I can again start working with my ones place, trying to build that up to a combination of 10. I see I have 164, so 4 ones, and 277, 7 ones. I'm going to work with 277 because it's closer to the next tens number. So I know that if I compensate and I take 3 ones from my 164, that leaves me with 161, but those 3 ones help 277 become 280. Now I look at 280 and realize that that is only 2 tens away from being 300. So I'm going to compensate again. I'm going to take 2 tens from 161, consider it 141, and give those 2 tens to 280, so I can consider it as 300. Now looking at that, I know that 300 and 100 more would be 400, and my sum would be 441. We're going to look at 164 plus 277 again, this time using the traditional algorithm for addition. When I look at my ones place, I see I have 4 plus 7. 4 plus 7 is 11, where 11 can be thought of as 10 and 1 more. But I can't record that 10 and that 1 more in the ones place. I can only record the 1 more. I have to take that 10 to the tens place. And now I have 10 plus 60 plus 70, which is 140. I can record that 40 in my tens place, but I have to take that new 100 I've created to my hundreds place. And now I have 100, 100, and 200, giving me 441. So when we do the traditional algorithm for addition, we are really thinking about creating 10 and then some more, just like we do in the Making 10 strategy. In conclusion, the Making 10 strategy allows for students to add numbers using the structure of the place value system and their knowledge of facts of 10. This knowledge can support the learning of the traditional algorithm for addition. I do welcome any and all questions, and you can feel free to contact me either by email or by Twitter. Thank you for viewing this video.